Something is happening in the constellation of Cygnus. Something that, according to our understanding of the universe, should be impossible. For the past several months, deep in the star fields surveyed by the Kepler telescope, a symphony has begun. A performance without a conductor, played on instruments the size of suns. The odds of what we're seeing are not just astronomical. They are functionally zero. We're witnessing a cosmic choreography so precise, so deliberate, it feels less like a coincidence and more like a declaration. It started when the James Webb Space Telescope turned its golden eye towards a planetary system 900 light-years away, and in the exact moment it began listening, the star at the system's heart erupted in a colossal flare. Annoying but normal. But then, another star, a sister star in the same cluster, did the same. And another. 7 suns, all flaring in a perfect, repeating sequence. This is the story of the Seraphim Cluster, a group of stars that suddenly began to sing in unison. And astronomers back on Earth are faced with a terrifying possibility. This isn't random. This is a message. The only question is what they're not telling us. We must investigate. What are the Seraphim really trying to say? Part 1, The Foundation. Our story begins not with a bang, but with a patient, unblinking stare. For 9 years, from 2009 to 2018, a lone sentinel drifted through the void, its gaze fixed upon a single, unremarkable patch of the night sky. This was NASA's Kepler Space Telescope. Its mission was a profound one, to count the worlds beyond our own. Stationed in the constellation Cygnus, the Swan, Kepler watched the light of 150,000 stars, waiting for the telltale dimming that signaled a planet passing in front of its sun. Kepler was a census taker for the galaxy. It didn't need to see the planets themselves. It just needed to see their shadows. It was a mission of pure statistics, a grand cosmic survey that would transform our understanding of our place in the universe. And it was a staggering success. Kepler found thousands of candidate worlds, revealing that planets are not the exception, but the rule. Our galaxy, it turns out, is teeming with them. Rocky worlds, gas giants, ocean planets, and lava worlds. A menagerie of possibilities. But Kepler's mission was only the first step. It could tell us that a planet was there and how large it was. But it couldn't tell us what it was like. For that, a new eye was needed. A bigger, more powerful, more penetrating eye. Enter the James Webb Space Telescope. A marvel of engineering. A golden honeycomb 1,000,000 miles from Earth, shielded from the sun's glare, designed to see the universe in infrared light. Where Kepler saw shadows, Webb could see atmospheres. It could analyze the starlight that filters through a distant world's air, hunting for the chemical fingerprints of water, methane, and oxygen. Hunting for the ingredients of life. In late 2023, the JWST's observation schedule was packed. Astronomers from around the world were clamoring for time on the multi-billion-dollar instrument. One of the targets was a system deep in the original Kepler field, a G-type star designated KIC 9837421, orbited by a promising super-Earth candidate. The goal was simple. Stare at the planet as it transited its star and try to decipher the contents of its atmosphere. A routine observation, another brick in the wall of our cosmic knowledge. But on this particular day, the universe had other plans. To understand what happened next, we have to understand the violence of stars. Our own sun, from our vantage point, appears to be a serene, constant source of light and warmth. It is anything but. The sun is a chaotic ball of nuclear fire, a roiling sphere of plasma governed by magnetic fields of unimaginable complexity. These magnetic fields twist, stretch, and snap like cosmic rubber bands. When they do, they release catastrophic bursts of energy. We call them solar flares. A single large flare can release the energy of millions of hydrogen bombs. It unleashes a torrent of radiation and charged particles that washes over the entire solar system. On Earth, they can disrupt radio communications, damage satellites, and even threaten power grids. They are the unpredictable tantrums of a star. And we are lucky. Our sun is relatively placid. Other stars, particularly younger, more active ones, are far more volatile. They can produce super flares thousands of times more powerful than anything our sun has ever thrown at us, capable of sterilizing the surfaces of any nearby planets. For astronomers trying to study those planets, flares are a nuisance. They are background noise, a sudden flash of light that can overwhelm the delicate signal they're trying to capture. They are a statistical certainty but a practical annoyance. You know they will happen, but you can never know exactly when. It is the very definition of a random, chaotic event. The crackle of a cosmic fire, without rhyme or reason. Which is why, at first, no one thought anything of it. The team at the Space Telescope Science Institute in Baltimore was monitoring the JWST's data feed from KIC 983-7421. The transit was underway, the light curve was looking clean, and the spectrographs were gathering photons. Then, without warning, the star's light output spiked. A massive flare, 10 times more powerful than a typical solar event. The sensitive instruments were saturated. The observation was ruined. It was frustrating. A waste of precious telescope time. The team leader, a fictional Dr. Eris Thorne, would later describe the mood as one of quiet resignation. They would have to reschedule. They began the process of recalibrating the instruments and moving on to the next target. It was a graduate student who first noticed it. While running a diagnostic on a wide-field guidance sensor, a camera that helps the telescope maintain its precise aim by tracking guide stars, she saw a flash in the corner of the image. Another star, not the primary target but one nearby, had also flared. She checked the logs. The second flare had occurred just under 90 minutes after the first. A remarkable coincidence. The two stars were known to be part of the same loose open cluster, a family of stars born from the same stellar nursery millions of a year ago. Perhaps, the team theorized, some shared filament of gas and magnetic fields had triggered both events. It was a stretch but not impossible. A scientific curiosity. A footnote for a future paper. They logged the event and moved on. But they couldn't let it go. In science, a pattern is everything. A single data point is an anecdote. 2 data points are a coincidence. 3 are a line. Intrigued, Thorne's team did something that wasn't in their original plan. They used their remaining observation time not to look at the planet, but to stare at the cluster itself. They widened Webb's gaze to encompass the whole stellar family, a group of 7 bright, young stars nestled together in the Cygnus field. They waited. For days, the stars behaved normally. They flickered and shone with the quiet dignity of main-sequence stars. The team began to think they had wasted their time, chasing a ghost. And then it happened again. First, KIC 983-7421, their original target, flared. The energy release was almost identical to the first event. Perfect echo. The team held their breath. They watched the clock. And 88 minutes later, right on schedule, the second star flared. Then, another 88 minutes passed. A third star, one they hadn't noticed before, erupted in light. Then a fourth, a fifth, a sixth, a seventh. A cascade of fire, sweeping across the cluster like a wave. 7 stars, flaring in a perfect, repeating sequence, each separated by a precise interval of time. The cycle took just over 10 hours to complete. And then, a day later, it began again, and again. A celestial clock, ticking with stellar explosions. The team was stunned. The word impossible was used more than once. The statistical odds of 7 independent stars flaring in such a precise, repeating sequence were so infinitesimally small as to be meaningless. This wasn't chaos. This was order. This wasn't a stellar tantrum. It was a symphony. A name was quickly coined, one that spread through the astronomical community in hushed emails and late-night video calls. The Seraphim Cluster. After the highest order of angels, beings made of pure light. The official story, when it finally broke, was a model of scientific restraint. NASA issued a press release. It spoke of unprecedented correlated flare activity in a young stellar association. It mentioned the star's shared origin and speculated about complex magnetic interactions. The leading hypothesis, they said, was a phenomenon they called resonant magnetic reconnection. The idea was that a shock wave from the first flare could travel through the thin interstellar medium, triggering a sympathetic flare in the next star, and so on, like a line of cosmic dominoes. It sounded plausible. It sounded scientific. It was designed to be reassuring, to paint this as a fascinating but ultimately natural phenomenon that we just didn't understand yet. It was a calm, steady hand on the shoulder of a very nervous public. But behind the closed doors of academia and space agencies, the mood was anything but calm. The domino theory had holes. Big ones. For one, the speed of such a shockwave would have to be astonishingly consistent to maintain that 88-minute interval between stars that were light weeks apart. It would have to travel without losing any energy, and it would have to perfectly target the next star in the sequence without affecting any others. And then there was the energy. The flares weren't diminishing as they went down the line. Star 7 flared with the same ferocious intensity as Star 1. If it were a simple chain reaction, you'd expect the energy to dissipate. The dominoes should get smaller as they fall. These didn't. The official story was a comforting blanket thrown over a deeply unsettling reality. But as the data kept pouring in from Webb and other telescopes that were now frantically being pointed towards Cygnus, the blanket was starting to look very, very thin. The spectral analysis of the flares was coming back, and the chemistry was wrong. The light from these explosions was showing an overabundance of specific heavy elements, in particular lithium and beryllium. These elements are delicate. They are typically destroyed in the fiery hearts of stars, not forged and ejected. Seeing them in such quantities was like finding a perfectly preserved fossil in the heart of a volcano. It made no sense. And the timing, the more they measured it, the more unnerving it became. It wasn't about 88 minutes. It was 88 minutes, 4.3 seconds. Every single time, down to the millisecond. Nature is messy. It is governed by probability and decay. It is beautiful, but it is rarely, if ever, this clean. This wasn't nature. This was engineering. The foundation of our understanding of the cosmos was beginning to crack. The official story was that we had stumbled upon a new and exotic type of star system. But a far more terrifying, far more profound possibility was starting to take shape in the minds of those who were watching. The possibility that the Seraphim Cluster wasn't a natural phenomenon at all. It was a beacon, a purposefully constructed, impossibly large piece of technology, designed to do one thing: get our attention. And it was succeeding. Part 2. The investigation. The official story is a comforting one. It tells us we have witnessed something new and wonderful, a previously unknown form of stellar interaction. It is a story of discovery, of expanding the catalog of natural wonders the universe holds. It is a neat, tidy explanation that asks for our patience while the experts figure out the details. But this investigation is not about the official story. It is about the details that don't fit. It's about the nagging questions that keep astronomers awake at night, staring at the ceiling and rerunning the numbers in their heads. The tidy explanation begins to unravel the moment you pull on a single thread. And there are so many threads. Our task now is to pull on them one by one and see what comes undone. This is where the real work begins. Part A. The anatomy of a ghost. Before the flares began, the Seraphim Cluster was known only by a dry catalog designation. It was just one of thousands of open clusters Kepler had surveyed. Open clusters are common. They are the stellar nurseries of the galaxy. A cloud of gas collapses. A flurry of stars are born at roughly the same time, and they drift together for a few 100 million years before the gentle tides of the galaxy pull them apart. They are a family, but a temporary one. The 7 stars of the Seraphim Cluster are young and energetic. They are F-type and G-type stars, slightly larger and hotter than our own sun, around 300 million years old. In stellar terms, they are boisterous adolescents, prone to the kind of energetic, flare-filled outbursts we are now seeing. On the surface, nothing is out of the ordinary. But when you map their positions in three-dimensional space, the first subtle strangeness emerges. The 7 stars are not scattered in a random clump, as you would expect from the chaotic process of star birth. Instead, they are arranged in an almost perfect geometric plane. Imagine 7 marbles placed on a sheet of glass. The deviation from that plane is less than 1%. Statistically, this is unlikely. Gravitational dynamics in a young cluster are messy. Stars are constantly tugging at each other, jostling for position. To find 7 stars of similar age in such a coplanar arrangement is a coincidence on par with finding 7 siblings who all share the exact same height, down to the millimeter. The official explanation? Observational bias. Perhaps we are simply viewing the cluster from a unique angle that creates the illusion of a plane. Or perhaps it's a rare but natural outcome of the way the original gas cloud collapsed. It's possible. It's just neat. Too neat. And there's more. Spectral analysis shows that their chemical composition, their metallicity, is virtually identical. This is expected for stars born from the same cloud, but the uniformity here is extreme. It's as if the ingredients for these 7 suns were measured out with a cosmic eyedropper. Again, not impossible, but it's another coincidence to add to the growing pile. Before a single flare was ever detected, the Seraphim Cluster was already an anomaly hiding in plain sight. A system with a strange, almost artificial-looking order. A ghost of a pattern waiting for the lights to be switched on. Part B. The impossible clockwork. Now we come to the timing. The beating heart of this mystery. A sequence of 7 flares, separated by an interval of 88 minutes and 4.3 seconds. Unwavering, unchanging, cycle after cycle. Let's be generous and first explore the mainstream explanation: resonant magnetic reconnection. The theory sounds impressive, and it's built on real physics. The idea is that the first star, let's call it Seraphim 1, unleashes a flare. This sends a shock wave of magnetized plasma and radiation outward. This wave travels through the thin gas between the stars. When it hits Seraphim 2, which is already primed and magnetically unstable, it acts as a trigger, causing it to flare as well. The process repeats, a chain reaction, a line of cosmic dominoes falling one after another. This is the best natural explanation we have, and it is completely, utterly inadequate. First, there is the problem of speed and distance. The stars in the cluster are, on average, about 500 astronomical units apart. That's 500 times the distance from the Earth to the Sun. Light itself takes nearly 3 days to cross the entire cluster. For a shockwave to travel between 2 of these stars in exactly 88 minutes, it would need to move at a significant fraction of the speed of light. While shockwaves from superflares can be incredibly fast, maintaining such a precise velocity over such a distance through the inconsistent medium of interstellar space is a fantasy. The space between stars is not a perfect vacuum. It has currents and density variations, like a choppy sea. A shockwave would be distorted, slowed down, and scattered. It would arrive late or early or not at all. It would certainly not arrive with millisecond precision every single time. Second, there is the conservation of energy. A shockwave is just a way of transferring energy. Like a ripple in a pond, it gets weaker the further it travels. The flare from Seraphim 2 should be weaker than the one from Seraphim 1. The flare from Seraphim 7 should be a pale shadow of the original. But that is not what we see. The data from the JWST is unequivocal. All 7 flares are of a nearly identical energy output, within a few percentage points. The chain reaction is not losing any steam. The 7th domino falls with the exact same force as the first. This violates basic physics. It's like shouting in a canyon and having the 7th echo come back louder than the first. Finally, there is the targeting problem. Why this specific sequence? Why does the wave from Seraphim 1 only trigger Seraphim 2, ignoring the other 5 stars, some of which are closer? The domino would have to be more like a guided missile, traveling on a perfect trajectory to its intended target, ignoring all others. To do this 7 times in a row is not a chain reaction. It is a calculated sequence. The domino theory, the best and only natural explanation on the table, fails on every single count. It fails to explain the timing, it fails to explain the energy, and it fails to explain the order. So we are left with the clockwork. A system that behaves with a regularity that nature simply does not produce on this scale. It is the difference between the random crackling of a forest fire and the rhythmic, deliberate beat of a drum. One is chaos. The other is intent. Part C, the chemistry surprise. If the timing is the drumbeat, then the chemistry is the message written on the drum. When astronomers look at the light from a star, they see more than just brightness. They see a barcode. By splitting the light into a rainbow, a spectrum, they can see dark lines where specific chemical elements have absorbed the light. Every element has a unique spectral fingerprint. This is how we know the sun is made of hydrogen and helium. When the JWST analyzed the light from the Seraphim flares, it found a barcode that shouldn't exist. The light was saturated with the spectral signatures of two specific elements, lithium-7 and beryllium-9. To a non-astronomer, this might sound trivial. To an astrophysicist, it is baffling. Here is the problem. Stars are fusion reactors, and their primary job is to destroy lithium. Lithium is a fragile element, the third lightest on the periodic table. The temperatures inside a star like those in the Seraphim Cluster are more than high enough to fuse lithium atoms into heavier elements. It's one of the first things a young star burns through. Stars are, by their very nature, lithium killers. To find an abundance of it being ejected from the surface of a star during a flare is like finding a snowman in a blast furnace. The official explanation for this is a process called stellar spallation. The idea is that the flare itself creates a storm of high-energy protons. These protons fly out and collide with heavier atoms in the star's atmosphere, like carbon and oxygen, shattering them into smaller pieces. Some of those pieces would be lithium and beryllium. In essence, the elements aren't coming from inside the star. They're being created on the surface in the heat of the moment. It's a clever idea. It almost works. But again, the details betray it. The process of spallation is messy. It would produce a whole range of light elements and isotopes, not just the specific ones we're seeing. Furthermore, the ratios are all wrong. Spallation produces lithium and beryllium in a predictable ratio, based on the physics of atomic collisions. The Seraphim flares show a massive overabundance of lithium compared to beryllium, a ratio that no known spallation model can account for. And the sheer quantity is staggering. The amount of lithium being ejected in each flare is equivalent to the mass of a large asteroid. To create that much material via spallation would require a flare so energetic it would likely tear the star apart. The energy budget simply doesn't add up. The mundane explanations have failed again. We are not seeing the chemical byproducts of a chaotic explosion. The spectral signature is too clean, too specific. It's not noise. It's a signal broadcast in the language of chemistry. It's as if someone has deliberately seeded the stellar atmosphere with these elements, knowing they would be unmistakable, knowing they are a sign of something that shouldn't be there. Lithium is a marker, a chemical flag planted on a sun. Part D, the deafening silence. As the scientific case against a natural explanation has mounted, the reaction back on Earth has fractured into three distinct camps: the official, the scientific, and the public. The official response from NASA, ESA, and other space agencies has become a masterclass in controlled communication. Press releases are vetted by committees, filled with cautious phrases like, "Further investigation is warranted," and a complex phenomenon that challenges current models. A planned press conference with the JWST team was abruptly canceled, citing the need to fully validate the data. The raw data streams from Webb's observations of the cluster are now subject to a proprietary review period, delaying their release to the wider academic community. The silence is deafening. Behind the scenes, we know that every major radio telescope on the planet, from the Green Bank Observatory to China's FAST telescope, is now staring at the Seraphim Cluster, listening for anything. So far, there has been only radio silence. But the act of listening on such a coordinated, global scale tells its own story. This is no longer just an astronomical curiosity. It is a matter of planetary importance. Within the scientific community, a quiet civil war is brewing. On one side, you have the gatekeepers of orthodoxy, figures like Dr. Evelyn Reed of the Max Planck Institute. In a recent op-ed for Nature, she wrote, "To leap to extraordinary conclusions when our understanding of stellar magnetohydrodynamics is still in its infancy is irresponsible. The universe is under no obligation to be simple. This is new physics, not alien physics. It is the voice of caution, of skepticism, the bedrock of the scientific method. On the other side are the intellectual provocateurs, figures like Dr. Kenji Tanaka at Caltech, a man often compared to Avi Loeb for his willingness to challenge consensus. On a popular podcast, he recently stated, "When an object exhibits characteristics that systematically violate multiple, well-understood laws of physics, we must have the courage to consider all possibilities. The timing is precise. The energy is non-local. The chemistry is artificial. If it looks like a duck, walks like a duck, and quacks in prime numbers, you must at least consider the possibility that you are not looking at a duck." This debate rages in journals and on university campuses. But out in the public sphere, the debate is over. The Seraphim Cluster is now a global phenomenon. Hashtag Seraphim sequence trends daily on social media. Speculation is rampant, from complex mathematical decryptions of the 88-minute interval to wild theories that the flares are powering a colossal starship. The world is mesmerized, excited, and terrified. For the first time since the Apollo missions, the entire planet is looking up at the sky, together wondering the same thing. Part E, a pattern of whispers. Perhaps the most unsettling thought is that the Seraphim Cluster may not be the first time we've seen something like this. We just weren't ready to understand it. Astronomers are now frantically looking back through old data, re-examining other stellar anomalies in this new light. Remember KIC 846-2852, Tabby star? The star that exhibited bizarre, unnatural-looking dips in brightness that nothing could properly explain? The leading hypothesis at the time was a swarm of comets, a mundane explanation that never quite fit the data. The new, whispered question is this: were we seeing the construction phase of a similar system? Were those dips in light not dust, but massive engineering projects blocking the star's light as they were assembled? And what of fast radio bursts, those millisecond-long blasts of radio energy from deep space, some of which repeat with a tantalizing, almost clockwork pattern? For years, we have explained them away as magnetars, a rare type of neutron star. But do they all fit that model? Or are we seeing components of a galactic communication network, of which the Seraphim Cluster is just the loudest, most obvious node? The context is shifting. These are no longer isolated mysteries. They feel like connected pieces of a puzzle we are only now beginning to see the shape of. The mundane explanations for each individual phenomenon are strained, but plausible. But when you see them all together, the argument for coincidence begins to collapse under its own weight. The investigation has led us here. The official story is in tatters. The evidence points not to a new law of physics, but to an old one, that of cause and effect. An effect as monumental as the Seraphim Cluster demands an equally monumental cause. The data does not suggest a natural phenomenon. It suggests a technology so advanced it is indistinguishable from magic. A technology that can command suns. We have moved beyond asking what is happening. The evidence is forcing us to ask a much more difficult question. Who is doing it? And why? Part 3, the speculative leap. We have followed the evidence to the edge of a cliff. Behind us lies the familiar landscape of known physics, of natural processes, of comforting, if incomplete, explanations. But the evidence does not stop at the cliff's edge. It points insistently outward, into a vast, uncharted abyss of possibility. The chain of mundane explanations is broken. The principle of Occam's razor, which tells us to prefer the simplest solution, now presents us with a paradox. What is simpler? A series of wildly improbable, unrelated natural phenomena that perfectly mimic intelligent design? Or the single, profound, and terrifying explanation that they are intelligent design? To continue our investigation, we must take that leap. We now leave the firm ground of observation and venture into the realm of pure speculation. This is a thought experiment. We are going to build hypotheses that, while extraordinary, are the only ones that seem to fit the bizarre set of facts laid out before us. We are going to ask the question the scientific papers cannot. If the Seraphim Cluster is a piece of technology, what kind of technology is it? What is its purpose? Hypothesis 1. The Great Beacon. This is the most direct and intuitive interpretation. The Seraphim Cluster is a lighthouse, a beacon, a signpost in the cosmic dark, built to be seen, built to be found. In this scenario, every anomalous property we've observed is not a puzzle, but a feature. The precise 88-minute timing is the pulse, the unmistakable rhythm designed to separate it from the chaotic noise of the universe. Nature does not produce clocks this perfect on a stellar scale. A civilization wanting to announce its presence would choose a signal that could not possibly be misinterpreted as natural. A repeating sequence of stellar flares is that signal. The planar geometry of the 7 stars is also a feature. Think of it as a stellar-scale phased array antenna. By precisely timing the firing of transmitters in an array, engineers can create a focused, directional beam of energy. Perhaps the Seraphim Cluster isn't broadcasting its light in all directions. Perhaps by firing the stars in this specific sequence, from their specific positions on a plane, they are creating a focused, directional beam of light and energy. A beam that sweeps across the galaxy like a lighthouse. Maybe we just happen to be in its path right now. This would also explain the consistent energy of the flares. It's not a chain reaction, but a series of powered, directed bursts, each calibrated to contribute to the final, focused signal. And the chemistry, the impossible abundance of lithium? In this model, that is the most brilliant feature of all. It is the color of the lighthouse's lamp. A species advanced enough to build this beacon would know that any emerging technological civilization would eventually develop spectroscopy. They would know we would analyze the light. By lacing the flares with an element that should not be there, they are adding a second layer to their announcement. The pulse says, "We are here." The chemistry says, "This is not natural. It's a signature, a calling card written in an ink of impossible atoms." The radio silence makes perfect sense in this context. Why shout into a hurricane? The radio spectrum is noisy, full of natural sources like pulsars and quasars, and a radio signal weakens with the square of the distance. To send a clear message across hundreds of light years would require unimaginable power. But a star is already a beacon of unimaginable power. Why build a new transmitter when you can hijack the ones that already exist? They have chosen a communication channel that is far more grand, more enduring, and, in a way, more elegant. They didn't build a radio tower. They taught sons how to speak. The question then becomes, why? Is it a welcome? An invitation to a galactic club? Or is it a warning? A lighthouse doesn't just say, "Here I am." It also says, "Beware the rocks." What dangers might lie in our cosmic neighborhood that would warrant the construction of a warning sign the size of a solar system? Hypothesis 2. The stellar engine. This hypothesis is, in some ways, even more humbling. It posits that the Seraphim Cluster has nothing to do with us. We are not the intended audience. We are merely ants on a railroad track, marveling at the rhythmic shaking of the ground, unaware of the continent-spanning locomotive that is passing by. In this scenario, the Seraphim Cluster is not a communication device. It is an engine. The synchronized flares are not a message. They are the exhaust. We are witnessing the operational cycle of a machine of incomprehensible scale and purpose. The 7 stars are the power source, the pistons in a stellar engine that is manipulating the very fabric of spacetime. The perfect planar alignment of the stars is a fundamental requirement of the engine's design, like the arrangement of cylinders in an internal combustion engine. They must be in that configuration for the machine to function. The 88-minute sequence is the firing order, a precisely timed cycle of energy extraction and conversion. What could such an engine be for? The possibilities are staggering. Perhaps it is a transportation system. The colossal energy output could be powering a wormhole, a gateway to a distant part of the galaxy. The Seraphim Cluster could be a stable, long-term transit hub. The flares are the waste energy, the splash and roar as the gate opens and closes every 88 minutes. Or perhaps it's a power plant. The builders of this machine may have moved beyond harnessing the energy of a single star with a Dyson sphere. Why contain one sun when you can network 7 of them together, drawing power from them in a coordinated, hyper-efficient cycle? The energy being drawn could be powering a civilization that spans the entire cluster, or being beamed to a home world light years away. This would also explain the strange chemistry. We see lithium and beryllium because those are the specific byproducts of the advanced physics they are using to tap the star's energy. It's not a message, it's industrial waste. The spectral signature is their pollution, the ash from a furnace that burns with a fire we have yet to discover. This is a profoundly humbling thought. It suggests we are not even a secondary concern to the beings who built this. Our frantic efforts to decode the message would be, to them, as meaningful as a microbe trying to interpret the chemical composition of a jet engine's exhaust. It is a stark reminder of our potential insignificance. We might not live in an empty universe, but one so full of titanic forces and grand projects that our existence barely registers. Hypothesis 3. The message in the medium. This final hypothesis is the most subtle, and perhaps the most likely if communication is the goal. It proposes that we have been looking at the puzzle all wrong. We have been behaving like a primitive tribe that finds a flashing LED light and becomes obsessed with the timing of the flashes, not realizing that the true information is encoded in the color of the light itself, in modulations too fast for the naked eye to see. In this model, the 88-minute cycle is not the message. It is the carrier wave. It's the dial tone. It is a steady, artificial rhythm designed to tell us, listen here, pay attention. The broadcast is about to begin. The real message is encoded within the flares themselves. And the key to it all is the lithium. Lithium-7 has a very specific nuclear property known as spin. It's the same property that allows doctors to see inside the human body using magnetic resonance imaging or MRI. What if the builders of the Seraphim beacon are using the abundant lithium they have created as a quantum data medium? What if they aren't just sending light, but light that has been carefully modulated at the quantum level? They could be encoding vast amounts of information in the polarization of the photons, or in the collective spin state of the lithium atoms as they are energized by the flare. Each 10-hour flare cycle would not be a single pulse of a message, but a colossal data packet. A cosmic hard drive delivered by light. The message wouldn't be a simple hello. Could be an encyclopedia. The laws of physics, a map of the galaxy, their history, their art. The accumulated knowledge of a civilization a million years our senior. This would perfectly explain the radio silence. Radio is an archaic, low-bandwidth way to send data. Think of the difference between sending a message with Morse code and streaming a high-definition movie. They are not using beeps and boops because they have mastered a form of communication with a data density trillions of times greater. They have written a book not in the alphabet, but in the fundamental properties of matter and light. We don't have the message yet because we are still staring at the cover of the book, marveling at the font. We haven't figured out how to open it and read the pages. The scientific community's next great challenge would be to design instruments capable of detecting these subtle quantum modulations. To build a reader for the stellar hard drive. This is, perhaps, the most optimistic of all the scenarios. It suggests that this is not a warning, and not an indifferent engine. It is a gift, a library card for the galaxy. It is the ultimate message in a bottle, thrown into the cosmic ocean, waiting for someone to find it who is clever enough not to just see the bottle, but to figure out how to pull the cork. And woven through all these possibilities is one final, disquieting thought. We assume the builders are alien. We call them they. But our own planet has been around for 4.5 billion years. Complex life for over 500 million. Is it not possible that a technological civilization has risen on Earth before? A civilization that grew so advanced it left our world for the stars, leaving behind no trace but a beacon program to activate when its younger siblings finally learn to look at the sky with the right kind of eyes? What if the message isn't from a stranger? What if it's from a long-lost ancestor, finally telling us, we're out here, come and find us? Part 4. The conclusion. And so, we arrive at the end of our investigation but not at the end of the mystery. The journey has taken us from the patient gaze of the Kepler telescope to the deepest speculations about the nature of life and technology in the cosmos. We have sifted the evidence, we have weighed the theories. But there is no final verdict. There is only the symphony, playing on, 900 light-years away in the heart of the Swan. The Seraphim Cluster continues its performance, indifferent to our confusion, our awe, our fear. It is a constant, a new and permanent feature of our reality. The sky is no longer quiet. We are left standing at a great fork in the path of human understanding, faced with two profoundly different interpretations of what we have witnessed. Each path leads to a completely different future for our species. On one hand, there is the path of prudence and caution. It is the path of known physics, of patient observation. This path tells us that what we are seeing is a cascade of remarkable, but ultimately natural, coincidences. It is a new chapter in astrophysics, a stellar phenomenon so rare and complex that we have mistaken it for a ghost. In this view, the planar alignment of the stars is a statistical fluke, a trick of perspective. The precise timing is a manifestation of a resonant magnetic reconnection that we simply do not yet understand. The impossible chemistry is the result of exotic stellar spallation processes that occur under conditions we have never before witnessed. This explanation demands no great leap of faith, only an admission of our own ignorance. It tells us the universe is stranger and more wonderful than we imagined, but that it is still governed by the same impartial, unthinking laws we have always known. This path is safe, keeps our worldview intact. It asks nothing of us but to be better scientists, to build better models, to keep watching until the strange new animal finally reveals its nature. But on the other hand, there is another path. A path that leads into the shadow. This path argues that a coincidence that must be explained away is no longer a coincidence. It is evidence. This path tells us to look at the facts as they are, not as we wish them to be. The geometry is not a fluke. It is architecture. The timing is not a resonance. It is a clock. The energy is not a chain reaction. It is a powered sequence. The chemistry is not a byproduct. It is a signature. This path argues that to ignore the overwhelming pattern of intelligent design in the face of so much evidence is not scientific prudence, but a profound failure of imagination. It is the story of a message, an engine, or a library. It is the story of them. This path is dangerous. It shatters our conception of our place in the universe. It suggests that we are not, and may never have been, alone. It forces us to confront our own technological and philosophical infancy. This, then, is the true meaning of the Seraphim Cluster. It is more than a celestial mystery. It is a choice presented to all of humanity. It is a test. Do we retreat into the comfort of the known, and label this anomaly a natural phenomenon to be filed away and studied for centuries, a puzzle for our descendants to solve? This is the path of safety. It is the choice to believe that the shaking of the ground is just a small, local earthquake, and not the approach of something far greater. Or do we embrace the terrifying vertigo of the unknown? Do we take the data at face value and accept the profound implication that something intelligent built this celestial clockwork? This is the path of transcendence. It is the choice to do the hard, world-changing work of accepting a new reality. It means dedicating global resources to listening, to attempting to decode, to preparing for a future where humanity is no longer the sole protagonist of its own story. It is the choice to admit that we are not the biggest thing in the forest, and to start acting accordingly. Right now, that choice is being made. It is being made in the quiet corridors of power, in the frantic, hushed conversations between scientists, and in the collective consciousness of 7 billion people staring up at the same sky. The great telescopes of the world are now a global network, all pointed at that one small patch of light. For the first time, our technological senses are truly united in a single common purpose. We are listening, but we have not yet decided what we are listening for. The constellation Cygnus will never look the same. For all of human history, it has been a swan, a mythological bird flying down the river of the Milky Way. Now, it is a question mark hanging in the cosmic dark. The flares continue to beat their steady, 88-minute rhythm, a celestial heartbeat that asks nothing of us, and yet demands everything. For thousands of years, we have lived in what we thought was a great silence, shouting our own questions into the void, and hearing only the echo of our own voices. That is the story that has ended. The silence has been broken. A sound has been returned. And we are left to wonder, as the light from those 7 suns washes over our small blue world, if we are meant to simply listen to the strange new music from the stars, or if we are being invited, at long last, to learn how to play.